Hello and welcome to Drilling Insight. I'm Jeremy Verduzco, host and editor of the Driller magazine. And with me today is co-host and drilling trainer, and of course, the driller writer, Brock Yorty. How's your world today, Brock?
It's great. I am full-time back in Michigan, and it's almost summer, and it's beautiful out.
Yes. I've enjoyed long walks with the dog and the wife, not necessarily in that order of preference, but it's been nice. Sun a little on the humid side, but I'm not complaining. So on today's show, we wanted to kind of put the focus on some troubleshooting issues. We talk a lot about safety. We talk a lot about protection and that kind of thing. We talk a lot about hiring, all of these issues. We want to talk about the drilling today. So I wanted to just do a one-on-one here with Brock because he is our resident drilling expert. And so really we kind of wanted to just start with, let's pick at two different sectors, maybe water well and geothermal. What does an ideal well look like? So let's set the baseline before we can talk about what goes wrong.
Sure. So both of them start very similar. We need the fundamentals of creating a borehole and having a drilling system. So, the right bit and cutting action for the specific geology, if that's sands and gravels into clay, or if that's clay into rock, we're going to run different bits accordingly. That's going to make sure that we have good size drill cuttings to be able to get them out of the borehole. So, bit selection is critical. And then we get into rotation and penetration rates. And with that, we have to be able to carry those things out of the hole. So if it's a drilling fluid like mud, that's coming up out of the hole, bringing those cuttings out, letting us progress. Sometimes it's air, which we also consider a fluid. Sometimes it's foam, or in some cases we do the reverse, where we have a negative pressure and the cuttings are coming up the drill string versus coming up and around. And so when we start all boreholes, from geotechnical to water well, geothermal, cathodic construction, the idea is to get cuttings out of the hole. And if that's mechanical, like with augers, or a core with a very small annulus, to a big borehole where we're flushing it out, then it's what impact can we have on that formation. So from a water well standpoint, everything is about us producing water out of the hole. So we're drilling this borehole, and the most important aspect is when we go through that confining layer, if it's rock, clay, whatever, into that aquifer, how do we make sure we don't damage it? So that as we're drilling, all that disruption we have, as we get into that porosity zone where all that water wants to start coming in, the water comes in and up, versus our force of our drilling phase pushes it out and starts cementing off anything that's in there. So in geothermal, we're not so much worried about producing water out of the hole as we are about making good footage, having a stable borehole that we can get loops into, that we can then grout and use as a battery or a heat sink. So water well and geothermal, we have a lot of good companies that do both. The major aspect is, as I get to the bottom of the borehole for geothermal, I still have time to reverse damage, clean up my drilling fluid to get my loops in. Where when I go for that final phase of water well drilling, as soon as when I push through, there's not that much hydraulic energy for that water to come up and out as easy as it is when we get, say, to 9 pounds per gallon drilling fluid to start causing damage. And so really it comes to, do I need water to come in, or do I need a stabilized hole to get loops into?
Yeah. So really, ideally you've got your bit selected for your geology, or, what you expect to be the geology, however deep you're going. You have cuttings removal. And then you have product installation in the case of geothermal, or extraction in the case of water or energy. So from there, like, still, I guess, keeping the focus on water and geothermal as some kind of smaller examples, what can go wrong? What are some things that can go sideways when I'm trying to do projects in either of these sectors?
Drilling method, tempo, rates is really what goes wrong. How if we're drilling into a fragile formation and we have a drilling fluid that we're running a mud pump that's, say, 300 gallons a minute, if we have a 12-inch hole, we're just right near where we need to be for uphole velocity. So the first thing to go wrong really in geothermal or water well drilling in general is being able to have enough velocity to bring the cuttings out of the hole. So if we're in hard formations with very little water and we're running air, we have velocities of, say, 1,500 feet per second or per minute, 1,500 feet per minute.
Yeah, which really kind of blasts the stuff up out of the hole.
And in order to do that, you have to have a hard outside formation. So we're cutting things, but it has a lot. It's not fragile. So then we get into something that's, sugar sand, very porous formations. And if you have that same velocity, you start making damage, and then you have hole erosion, and then we collapse. So if we switch from air to mud, let's say we're going to drill a 12-inch water well and we're drilling a 6-inch geothermal hole. We won't run the mud pump at the same amount of fluid volume, because the max we want is about 150 feet per minute uphole velocity. So for 150 feet uphole velocity at a 6-inch hole, you're looking at, 125, 150 gallons per minute. And that mud pump can do 300 gallons a minute. And then as we look at that 12-inch hole for the water well, 300 gallons a minute is really about 50 feet per minute uphole velocity, which is basically on the bottom edge of, if we think of our drill solids as a space shuttle breaking our gravity to go. And right now with, Dragon and, all of those shuttle launches, we can watch a lot of cool shuttle launches. And the big thing that's changed is we can recover those jet propulsions that we need to break Earth's gravity. If we didn't have the right amount of propulsion, that shuttle would start to vibrate and would start to break apart and wouldn't be able to break our velocity. It would either fall and crash, or it would just vibrate apart. And we've seen tragic incidents like that. Same thing happens in drill cuttings. We need that optimal uphole velocity to keep that solid intact from, say, we want a 1/2-inch to not bigger, really, like we're looking at a nickel size to a quarter size is what we're looking for solids. And that's where our optimum uphole velocity comes from. But when we fail at that, that's when we start seeing hole erosion. We get to a point where solids are coming in on us. We can get pipe stuck. Those are the things. We start seeing our rotational torque go up. We start making damage to the hole that's irreversible, and then that's where we fail.
So talk to me about that balancing act where you're trying to judge how much fluid and pressure to put down hole versus what's coming up. Like, how are you weighing that balancing act?
This is where we switch from the engineered aspect to everybody's rig is going to be different. It's going to be tooled a little different. It's going to be plumbed. Some will have piston pumps that do 200 gallons a minute. Some will have centrifugals that do 300 gallons a minute. Some will have large pumps, different. So what happens is we have to balance that with our rotation, rate of penetration, and the size of the solids coming out of the hole. So if I grab my little strainer and I start looking at the hole and I'm looking at the cuttings coming out, and there's somewhere between that nickel and quarter size, 1/2-inch to 1-inch, I'm good.
You're winning that
Yep.
hole.
And I can change my rotation. to change the size of my cuttings. Now, if I get into a situation where I'm starting to get little cuttings from coming out, and then I start getting big chunks at different phases, I need to slow down my penetration rate. I need to
You're at that point, you're getting a little over your skis.
Yes, yes, absolutely. It's kind of like my wife loves to make smoothies, and sometimes she'll throw ice and the bananas and the ice cream in there, and then she'll want to put it on chop instead of smooth, and when you or vice versa, and it's overwhelmed. It can't rotate, and so that's where we get into trouble when we get laser focused on how many feet we can get in per minute, and we stop looking at our gauges, because our rotational torque will be going up, our pressures will be going up. We'll start creating those cuttings that can't get out fast enough, start to coat around our drill steel and start to make what's called a boot or a plug, and then that's when we start causing damage.
Yeah, yeah. So what are some you talked about pressure, you talked about cuttings. What are some other things that can go wrong, or that the kind of 2.0 or 201 level class stuff that an entry level person might like to hear about?
So I think our biggest issue is it's easy to say Mother Nature threw us a hard curveball, and that's why we got into problems. And in reality, I'd say only about 25% of the time do we actually have something that Mother Nature threw at us that we couldn't overcome. So then it 100% comes back to our technique, our behavior is at 75%. So the curveball comes from, not recognizing that I'm continuing to get the penetration I need, and I need to trip out and put on a different bit. So let's say we were drilling sands and gravels, and then we got into a heavy shale. And the sand and gravel bit I had on was making great penetration. And then I got into this shale that was reactive, and it's making these big chunks. And I'm starting to boot off, and my penetration rates went down. And I've turned my mud pump all the way up, but I'm still not getting cuttings out of the hole. That's a time where we have to say, do we continue to struggle through this? Or do I trip out and do I put on, a mill bit with longer teeth? Or do I go to a drag? And I believe we can remedy many of our problems by just going, it's time to switch methods. We have carousels, we have good rod handling. Everybody in the industry loves to talk about tripping out and how fast they can do it. We should practice, making a bit trip, recognizing that, there's times that the best solution is to put the better tool on.
Yeah, yeah. And I can imagine picture being at the controls and thinking, oh, maybe it's just a small layer that I'm going through. I don't want to go through the trouble. It's going to take time, a lot of pressures of the job to make footage. I can imagine being resistant to wanting to bring the whole thing out and put new tooling on. So that kind of shifts to my next question is, like, how do I be proactive? How do I kind of get ahead of these things? It sounds like maybe, spending some planning time might be in order.
It is. In the States, it's very easy for us to pull up well logs, USGS logs, talk to an industry friend and colleague and look at what we have in the area. We shouldn't really get into situations where we're like, holy cow, this was all sand and we thought it was going to be clay. Or I hit rock at 5 feet and there's no way we should have had rock here. So we have some pre-planning, but also being versatile. So looking at the day starting, making sure I have the couple bits that I need in my toolbox, making sure that I can switch from mud to air if necessary. Or there's great tooling out there now that we can tool up reverse much faster than we were before. So, it's hard because rigs, knowing your capabilities of your rigs and knowing your limitations are so important. But if you got a straight mud rig and you're a mud driller and you don't have enough air, you know that you can call the United Reynolds or another rental facility and get a air compressor you can plumb in, and then you can look at running foam or something like that, or vice versa. It's good to have a auxiliary mud pump if I'm a big air rig for the times that I need to have that. There's so many different ways to get to the bottom of the hole. It's just how much time and fuel do I want to spend? And that's where we get in trouble, is going, I, we have to make the rule. We have to go, if I can't get through this when my penetration rate slows to, you know, 6 inches an hour or what, it's got to be your company's rule. But really for me, it goes, if this hasn't worked for 15 minutes, we circle up, me, the driller, the helper, what can we do to adjust? And it comes back to that joke that we've had forever about who wants to be a driller. And let's ask the audience. Let's talk to our crew. Let's see what's different. Let's just, we don't have to go at it alone. And that's very much back to the whole rocket ship concept. We don't have to be at the stick and make all the decisions. We can do group think and come up with a better plan.
Yeah. If you want to go farther, go together. And so, as many in the audience know, you answer questions like we've been going through all the time on your own Ask Brock show that you can find on our website. What is, if someone wants to get a hold of you to ask a question or to find out more, how do they get a hold of you, Brock?
Email questions@askbrock.com. My phone number is at the end of every driller article that's out there. So I get text messages, I get emails, I get phone calls. I just recently got a phone call that went, I'm running reverse. I was told that I needed to run easy mud, DP, and all the company had that I went for was Polybore. And I'm a classically trained Bayroid mud guy, so I knew those products. And they said, well, we got it mixed up into solution and we got going and we're running reverse and it was going great. And I would say that's another aspect of our industry. There are many times where things look like they're going great, but the end result can be hard. And so a large polymer giving us a big viscous drag to help bring up material, including inhibiting, works well. But then we get into that porosity zone and we realize that large polymer that's going to continue to hydrate has no filtration control. And now it's out into that porosity zone. And so we just had a big discussion about how do we break up that polymer. And I will say, I hear that question 20 times a year about, I'm just going to run a straight polymer because straight polymers are all I need. I drill all over the country and this is what I'm going to do. And it's not, traditional light bentonites, getting a good fluid, or if I'm running a foam, we cause our own problems. It's all about the damage we do to Mother Nature that was already there. And that's the key, is understanding how can I minimize that damage to have the best hole possible to put in loops, cathodic. If it's a water well, we have more stages. We gotta set the screen. We got to, casing, then we got a gravel pack, and then we got a grout. There's more steps. Therefore, we need more time. We need a better hole.
Yeah. Well, in some of this, it sounds to me that you can work backward from from the bid that you do, from the quote that you do as a contractor, and build some of these things into your quote and not undervalue on the front end to where you get to a difficult part in the job and you don't have the tools or the resources you need, and then you've got to go back to the client anyway.
Success is about consistency. Success is about knowing that I can do 9 out of 10 wells without a hiccup. Now, maybe those 9 wells took longer than, say, a company that is really fast at drilling and they do 5 wells faster than my 9, but the following, 6, 7, 8 are all problematic, and we've ended up with the same amount of time in our work, and we're trying to develop out because we've gotten stuck on water wells. But um, the idea is come up with your plan and absolutely, I guess I'm going to have to quote Marvin Gloffelty again with the Art of Water Wells, or Thomas Hanna with Johnson. Um, or, the Roscoe Moss guys have been excellent with me to work with lately. And they all say, all right, this is our production zone. What gravel pack are we putting in? Then what screen? And it comes back to our borehole size. And so if we look at from the water coming in to surface, how do we get there? We start seeing that. And it's a very good psychological behavior to have for us to think, instead of, I'm going to drill a well, what tools do I need today? And the first thing we say is a drill. And then we say some drill rod and maybe a bit. But if we go, all right, I just punched through. No, even better. All right, gravel pack set, screens in, gravel pack set, it's grouted, water's coming in the hole. How did I get there? Okay, well, at 187 feet, that was the bottom of the best formation, and it ran from 187 to 177. And I ran a 12-inch bit, and I'm going to be putting in, 8-inch casing. Can I get enough force through my screen and gravel pack in order to develop up that filter cake? Or I'm running reverse. Do I have a stable hole as I come out? It all comes down to the damage we do that we have to prevent. And if we think of it that way, that we're a disruptive process, then we're able to, drilling projects aren't hard. We psychologically make them hard. We can either be surgical or we can go in with a hammer and smash the shit out of everything. And we like to smash stuff.
Yeah. Well, and you kind of alluded to the point of keeping good notes. And I think that's, every hole is going to be different, of course, but if you keep good notes over a long time, you're going to build up, quite a reference library that you can go to and say, well, I was, a quarter mile down the road here 4 years ago. This is what I found. This is what I used. This is what brought success there.
Absolutely. Multiple mentors have said your strongest memory isn't as concrete as the faintest ink, right? So it's like, we're going to continue to be on projects. We're going to have problems. How did we remedy those problems? Not changing everything at once is a big issue. Realizing that, okay, I slowed rotation down, and I increased my mud pump. Okay, that didn't quite work. I'm going to increase my mud pump, and I'm going to slow down penetration this time. What got us there? But then notebooks. And I've talked about this a couple times now, but as we get with regulators and engineers, you're the book. So when you say, oh, okay, guys, you want me to drill this 20-inch hole and put in 14-inch casing, and this is all stupid. Instead, we have to go back and go, these are the problems if we construct this well this way. And you be the book because you have your notebook and you have those documents. And that's the only way we can have that credibility, is to have the notebook. And so I take notes all the time.
Yeah. And it gets easier than ever with, everyone has a smartphone in their pocket. They can document everything. And, even if you write stuff down, you can capture it on a photo, and it'll be there, 10 years from now when you've lost the notebook. So Well, I think this has been an informative conversation. I do appreciate your time sharing all these great ideas, Brock. I think it's this will be a good resource for folks to, kind of listen to and wrap their head around it, actually, whether they're in the industry or not. So thanks for your time today. And as always, you can find fresh episodes of our show on our website or on Apple Podcasts every other week. Search Drilling Insight and hit that subscribe button. And you can visit thedriller.com for the latest industry news and views. And don't forget to follow us on the usual social media channels. Until next time, this is Drilling Insight.